Hello, my name is Gene Burr. I'm a service engineer with CNC Engineering. At CNC Engineering, we provide our customers with economical resolutions to machine control problems. We also provide rotary table interfacing and probing options. Today we're here to learn some of the functions of the FANUC control that you could use to troubleshoot. The function that we're going to test today, or use today, is the trace function of the PMC control.
PMC Trace Function gives maintenance personnel the opportunity to monitor and track signals in and out of the PMC. But in order to set up our trace, we have to get to the trace screen. So let's look at our control here. To use the trace function, we're going to go to System, Next Page, PMC Maintenance, Next Page, and trace setting for our trace parameter settings. If you don't have access to the trace screens, reference your controls parameter manual to set your CNC operation screens. We're actually going to start with page 2 of our trace settings. This is where you tell the CNC which signals you want it to pay attention to. This could be an X address, R address, F addresses, and so on. But keeping in mind that each signal you add shortens the time available for the scan. Once I finish with that, I will head back to page 1. This is where I'll tell the CNC which type of trace I want to run. The main parameter here is us decide between two types of modes, time cycle and signal transition. This determines when the CNC captures the information for your scan. Our first option is time cycle. This setting could also be described as continuous scan. Whenever we set for our resolution, the CNC is going to take and record a snapshot of that interval every time. Time cycle mode allows us to get an accurate timeline of events. It also allows you to use the mark tool to measure in time instead of having to calculate it on your own. The second trace mode is signal transition. This is the conditional scan. While the trace still monitors the signal according to your resolution, it's only going to actually record that information, that is, take a snapshot if certain conditions are met. Benefit of this type of trace is that you aren't stuck in a specific bracket of time. This is my preferred mode, and I'll show you why in an example later. Under the trace mode, we have two settings, resolution and either time or frame. Resolution controls how often the trace monitors your listed signals. You'll usually want to keep this number small to make sure you catch quick transitions. Our smallest resolution is 8 milliseconds, and it is usually what I recommend. But if you're looking for less detailed data over a long period of time or watching a large number of signals, increase the resolution will increase the amount of time you have to trace recording. The time or frame field determines the maximum length of scan. We'll see time here if we're using time cycle and frame for signal transition. What this actually means is determined by what you select in your stop condition. But for now, just remember that the more signals you have and monitor, the smaller it's forced to be.
For our stop condition, we have three options: none, buffer full, and trigger. These predictably determine when the trace stops. The easiest to start with is buffer full. Unless you stop it manually, this type of trace will run until you hit the limit set in the time or frame, and then end on its own. Don't get this confused with none. If you set none as a stop condition, the trace will continue until you manually stop it, overwriting old information if it exceeds its time or frame size. The last stop option is trigger. When you select this, you can see several fields below it become available. Trigger allows you to set conditions for the CNC to stop trace on its own based on the state of a specific address. Just below the stop conditions mode lets you determine which state the address needs to be in to trigger the stop, rising edge, falling edge, or whichever happens first. Last in this section is the position. This tells the CNC how long you want to record after you stop triggers. Be careful here, the percentage is actually how much of the trace you want to have happen before the trigger. 50% will instruct the trace to continue equally as long after the trigger as before it. If you're in time cycle, our final set of fields will be grayed out. They're only for use with signal transition mode. Remember that signal transition only records data under certain conditions. This is where you determine those conditions. You can set this field to any change, which will tell the trace to take a snapshot anytime there is a state change in the monitored signal. But my favorite mode is trigger. The trigger condition lets you use an address to control when the trace information is recorded. This is a powerful tool that works very differently depending on what you choose for its mode condition. 3 of these are what I like to call snapshot conditions: rising edge, falling edge, and both edge. Because the edge conditions are only active for one scan, the data they capture typically ends up choppy and nonlinear. It's useful in situations where the quantity of data is more important. How many times did the lube pump turn on over a course of a workday? And what were the states of various switches when it happened? The last 2 sampling modes I like to refer to as continuous conditions, on and off. If continuous sounds familiar, that's because it's just like our time cycle mode, which you can use these sampling modes to emulate. Unlike the edge conditions, on and off will capture the trace so long as the trigger address is in the right state. This is why I like signal transition. If I tie it to the right address, I can essentially create a time cycle trace with a start condition. And that's the last of our trace parameter settings. But next I'm going to show you how to set up and read a signal transition trace. So for this example, I have a scavenger pump. I want this pump to run for 10 minutes after I hit the e-stop. But I suspect that it's not actually staying on that long. I don't feel like standing around with a stopwatch. So I use a trace to investigate. Starting on page 2, we're going to decide which signals we want to monitor. So I'm going to put in the address X8.3, which is the confirmation signal from the pump. Back to page 1. Now in this situation, I care about timing, so I could use a time cycle trace, but instead I'm going to show you how to use a signal transition mode to create a start trigger. My resolution, I'm going to set 100 milliseconds. Notice how it sets itself down to 96. The CNC automatically sets the resolution to the nearest multiple of 8. The frame I'm going to set to the maximum available. There's really no harm in doing so, and it gives me the most possible time to capture the change I'm looking for. I'll set my stop condition to trigger. What I'm looking for here is the moment when the scavenger pump turns off. So I'll set my trigger address to X8.3, which again is my scavenger pump confirmation signal. And I'll set my stop mode to falling edge. That is when the confirmation signal goes low. The position selection I'll set to 100%. I don't feel as though I'm having any issues with the switch bouncing or the pump somehow toggling on or off, so I'll just cut the scan off as soon as I see my stop signal. Now the part that makes this like a time cycle is I'm going to set my sampling condition to trigger and set trigger to my e-stop input, X8.4, and then I'm going to set my signal mode to off. If you remember, this means that I'll be capturing trace information so long as my e-stop signal is low. So to actually run the trace, pop on over to the trace page and hit start. Nothing seems to happen on the graph, which is good. We haven't met our signal condition yet. Now, when I hit e-stop, there it goes. In this case, e-stop has me tied up, but I could go run a part program, set work offsets, get coffee, whatever I needed to do while the trace runs. But while I was talking, I noticed it stopped. Definitely not 10 minutes. But now we get a chance to look at the reading on the graph. We have 3 best friends on the trace page: zoom in, zoom out, and mark. The one you're going to make friends first with is zoom out. While you can scroll through the trace using the arrow keys, it takes a long time. Previous and next get there a little faster. They move the graph over a full page, but then when you start getting really lengthy traces, the best way to get around is just zoom out, scroll over, and zoom in. Notice that the zoom in function centers itself on your yellow cursor, so be sure to have the highlighted area wherever you want to try zooming in. When you read a trace, you're going to come across 3 types of boxes: white, black, and gray. A black box means that the signal is low or off. A white box means the signal is high or on. And sometimes you'll spot gray speckle boxes. A gray box means that you're not zoomed in enough, so you're not catching the actual start of the signal. Once I found my starting point and confirmed that it's completely white box, I'll hit mark. A blue line appears that looks a lot like my cursor, but it stays put when I move it around. This is your mark. Notice that the top of my range field is changing. This is telling me the number of frames between that blue mark I set and the cursor position. The green bar indicates my stop trigger. Because I set my position to 100%, it's right at the very end. So I can use my zoom out and zoom in keys to scroll all the way to the green bar and realize that the range now matches the mark position. The mark position field tells you how far the mark is from the end of the scan. Because the mark is to the left of the scan end, this number is negative. But what we set out to do is figure out how much time actually passed between pressing the e-stop button and the scavenger pump turning off. If we'd done a time cycle trace, all these measurements of range and mark position would already be in milliseconds. Here we have it in frames, but we can fix that easily. We know that from our range and mark position fields that the pump ran for 52 frames from the start to finish. And we look back at our resolution, we remember that each frame has passed 96 milliseconds apart. So we pull out our handy pocket calculator and realize that 52 times 96 milliseconds is 4,992 milliseconds, or approximately 5 seconds. Definitely not 10 minutes, so clearly something has gone wrong here. A difference this large is going to be something I could notice on my own. But the tools used in this example can expand and apply applications across the full range of CNC operations. The ways you can use the trace function are nearly endless, which is why it's a great tool to have in your troubleshooting toolbox. And you can always check your maintenance manual for more information. Thank you. I hope you enjoyed our presentation. Have a good day.